The world runs on tiny pieces of silicon. They sit inside massive data centers, inside research labs, financial systems, and tools. Millions of people use them every day. Most of us never see them or never think about them, but these chips power everything. But what would happen if the most advanced AI chips in the world suddenly started failing? I mean, like some car companies recall their cars because some features aren't working properly. The same way, what if big chip companies like Nvidia, Cerebras, or any other say in the coming future that we are recalling our chips because of XYZ reasons? At first, it may sound small. A technical issue, a hardware defect, a precaution. But within hours, the scale would become clear. Because today's digital world depends on a very small number of extremely powerful chips, and those chips sit at the center of everything. Modern systems rely on them to process huge amounts of information. They support research, finance, logistics, design, communication, and countless other industries. They are the engines behind the scenes, quietly running day and night. If those engines stopped working reliably, even for a short time, the ripple effects would spread quickly. Companies would pause critical operations, large computing facilities would slow down or temporarily shut off systems. Engineers would begin urgent testing to identify affected hardware. Replacement demand would skyrocket overnight, and suddenly, a piece of technology most people never think about would become the most important story in the world. Why would a recall be such a big deal? Well, because advanced AI chips aren't like everyday consumer electronics. They aren't produced in small numbers, they aren't easily replaced, and they aren't simple. Each one represents years of research, engineering, and testing. Manufacturing them requires specialized facilities, rare materials, and extremely precise processes. Replacing large numbers of them quickly would be almost impossible. If a major flaw were discovered, overheating risks, calculation errors, or stability issues, companies wouldn't have the luxury of ignoring it. They would have to act fast, and acting fast at that scale would be incredibly difficult. Data centers around the world would need inspections. Systems would require updates or replacements. Production lines would be pushed to their limits. Every company relying on those chips would be affected in some way. This doesn't mean everything would collapse, but it would slow down. The digital world runs on speed, instant responses, real-time processing, continuous uptime. A sudden recall of critical hardware would interrupt that rhythm. Think of it like grounding aircraft for safety checks. Flights don't stop forever, but schedules change, delays spread, and the system feels the pressure. The same would happen here. Businesses would adapt. Engineers would fix issues. New hardware would be deployed over time. But the incident would reveal something important: just how dependent the modern world has become on a small number of highly advanced machines. We often talk about software risks, security breaches, data leaks, system outages. But hardware rarely enters public conversation. It operates quietly in the background, assumed to be stable and reliable. A large-scale chip recall would change that perception overnight. Suddenly, the physical foundation of the digital world would be visible to everyone. Questions would be asked. How resilient is our infrastructure? How quickly can replacements be built? What backup systems exist if critical hardware fails? These aren't dramatic science fiction scenarios. They're practical questions about reliability and scale. Because as computing systems grow more powerful, they also become more concentrated. More capability sits inside fewer, more advanced components. That concentration brings efficiency, but also vulnerability. If one part of the system experiences problems, the effects can spread further than expected. This is why companies invest heavily in testing, monitoring, and quality control. Why does hardware undergo intense validation before deployment? Why redundancy and backup systems are built into major facilities? The goal is simple: prevent failure before it happens. And most of the time, that approach works.